no more work with related rates today. Wednesday, I'm going to give you a take-home quiz that will be due Friday. And Friday in class, we have an in-class quiz. It's a group quiz. You already have the quiz. It's the first page of your packet, so you can look at it ahead of time. You have the answer. It's on the back of the quiz. So you just have to figure out how to get that answer. Okay, you can talk to each other, work on it ahead of time, whatever you need. Then I'm going to collect it in class. And then Monday, your data project is due. Okay. So if you did a little work on the related rates quiz before class on Friday, you might be able to use the remainder of that time to work on your project if you needed it.
Sorry, what is the project due?
The 23rd, Monday, a week from today. Okay, so we're going to do some more related rates problems today. I'm going to do one example because it's a little bit different than the kinds we've seen before. Before we start, though, I just want to point out that your questions of the day that are due next class, rather than reading, it involves watching a short YouTube video. The link is at the bottom of your packet where it says questions of the day. It's a fun little video. I think you'll like it. Okay, so let's do this example. Ship A is sailing north and ship B is sailing east. Using an XY plane, radar records the coordinates of each ship about every so often. So we've got time and then the X and Y coordinates of each ship. All right, so the question is approximate the rate at which the distance between the ships is changing at t equals 5. So the key word here is approximate, right? Because usually there's like what we know, what we want to know, and what you know is just stated right in the problem. Like you know that dx dt is some value, right? But they didn't give us anything except some table of values. Okay, so let's see if we can still write out what we know and what we want. So we're going to have to assign some variables. So this is a triangle right here. So I'm just going to draw this in. And this x value right here is 1.77. So the vertical side of that right triangle is at x equals 1.77. And then this y value that's the horizontal side of the right triangle, that's at 1.24. So in the xy plane, the distance from the right angle in the right triangle to ship B, right? This is ship B that's traveling east. This is ship A that's traveling north. Okay, so the distance from this point to point B, let's call it x because it's a horizontal distance, but it's actually x minus 1.77, right, if we're talking about distance in the coordinate plane. So we'll do x minus 1.77. So what would that vertical distance be from the right angle up to ship A? Y minus 1.24. Yeah, this is at a distance of 1.24, and then this point is at 1.24 comma y. Right? So I want you to ignore these points right now because ships A and B are moving, right? So those distances are varying. They're not static. Okay, and then the question I was asked was about the distance between the ships A and B. The direct line distance between the ships, we can call that h. All right, so let's see. What do we know? What do we want? What we want is easier in this question. Okay, what we know is a little tougher. But what we want is the rate at which the distance between the ships is changing at t equals 5. Okay, so how can I express the rate at which the distance between the ships is changing? dh dt. So I want dh dt when t is 5. Good. Okay, so what I know is a little tougher because it wasn't obviously given. All I have is some data. But according to my picture, the other important variables in this problem are x and y, right? So could I estimate dx dt and dy dt? Yeah, how do you estimate a derivative? Estimate an instantaneous rate of change. The average rate of change over the smallest interval that we can. Yeah. Yeah, so I'm like sending you back to like our first day of class here, right? Not necessarily, but we're interested in the time t equals 5, right? So I want to estimate dx dt and dy dt when t is 5. Okay. So dx dt and dy dt when t equals 5, right? So I know approximately I can figure those out, can come up with an estimate, which is okay because the question said approximate dh dt. So let's figure out what those are first before I start trying to solve my related rates problems. I need to know the things I know. So dx dt and dy dt when t is 5. So if I look at dx dt, x is the distance of the location of ship B, right? That's what's changing there. So here's ship B, and I want dx dt when t equals 5. So this is the best information I have regarding ship B around time t equals 5. So let's approximate dx dt using a difference quotient. So dx dt, that's just shorthand for a really small change in x over a really small change in t. I'm going to use a relatively big change because that's all I've got, right? So my change in x would be 6.08 minus 5.8. Change in t is 5 minus 3.75. And you get 0.25, nope, 0.224. Okay, so that's an important value. And then for ship A, the information I want regarding ship A is the change in y because A is moving north-south. So for A, I'm going to use those times and the change in y. So dy dt is approximately, the change in y would be 3.67 minus 3.35 over the change in t, which is 5 minus 3.75. And that comes out to 0.256. So everybody kind of remembers estimating derivatives. We haven't done it in a long time. It's just the slope of a secant line instead of slope of a tangent line. All right, so now I have what I know. I have what I want. I have a picture with all my important variables. I need to write an equation that relates my important variables, x, y, and h. Can you relate those in an equation? Mm-hmm. Pythagorean theorem, yeah. The legs of the triangle, square the legs, and you get the hypotenuse squared. All right, so now the rest of this related rates problem is exactly like what we've done before. It's just that what we're plugging in are approximations of dx dt and dy dt. So at this point, I take d dt of both sides. So that means just take the derivative of both sides, where your independent variable is time. Okay. So neither x, y, nor h are the variable that represents time, which means that any time I take a derivative that's not t's, you're going to have to use the chain rule. Okay. So if I take d dt of x minus 1.77 squared, that's some stuff squared. So I bring down the 2. Oops. I copy this stuff. But then I have to multiply by the derivative of the stuff. It's not 1, it's dx dt, right? Because the independent variable is t, right? So the derivative of x is not just 1, it's dx dt. Okay, then we do the same thing on the next term. So I bring the 2 down. Y minus 1.24 to the first times the derivative of the stuff inside, which in this case is dy dt. Do the same thing to the h squared. It becomes 2h times dh dt. Easier to take the derivative, but just a personal preference. What? Yeah, if you had the square root of the whole left side equaling h, there would just be more steps in taking the derivative of the left. Yeah. What? Yeah. Yeah, I'm looking for dh dt, but I'm not solving for it yet, right? I'm just taking the derivative of h squared. 2h, do the power rule, times dh dt, the chain rule. If that was just an h there, if that said d dt of h, then its derivative would be h dt, dh dt. But it's h squared. Oh, good question. So at this point, dh dt is the thing I'm looking for, right? That should be the only thing that I can't replace with a number. Okay. So let's go through and try to replace things. Okay, what is x at time? I'm interested in time t equals 5, right? That's what they asked about, dh dt when t equals 5. What is x when t equals 5? This x. We defined x to be the distance of ship B, right? 6.08, yes. So x when t equals 5 is 6.08. Okay, so this is 2 times 6.08 minus 1.77. dx dt I have an approximation for 0.224. Yeah, sure, you could do that. Divide 2 out of everything if you want. I already started writing it, so I'm just going to keep going. What is y when t equals 5? Yeah, y is representing ship A. So we look at ship A at time t equals 5, 3.67. So this is 3.67 minus 1.24. dy dt was approximately 0.256. Okay, I need h. And then dh dt is the only thing left unknown. So h, when t equals 5. So h is the hypotenuse of this triangle, right? I know what x and y are. I'll just use the Pythagorean theorem. Yeah. So X was 6.08 and Y was 3.67. So I'll maybe draw a snapshot on another piece of paper. This is X. And this was Y minus 1.24. So X 6.08 minus 1.77 squared plus 3.67 minus 1.24 squared equals H squared. So this is my snapshot at time t equals 5, right? Because I know X and Y at those moments. So I solve that. I don't think I have it on here. Okay, so let's have the calculator figure out H here. Oh, that doesn't sound right. Yeah, it's 4.9, if I remember it correctly. Yeah. So here you get, when you solve for H, you get H is approximately 4.9. It's okay, again, to use approximate values because the question asked us to approximate. Okay, so at the moment in time I'm interested in, H is about 4.9. So I go back to my equation where I'm filling in all the stuff I know, and I put a 4.9 in for H. And then I just solve for dH dt. So let's, maybe at this point I'll divide the 2 out of everything. Divide everything by 2, those all go away. And then have my calculator simplify this. That's okay. The Pythagorean theorem at time t equals 5. No, because the length of the triangle side is not just plain old x, it's x minus 1.77, and this is y minus 1.24. So you take the values for x and y from the table, plug them into your Pythagorean theorem equation. Okay, so 6.08 minus 1.77 times 0.224, 0.96544. .67 minus 1.24 times 0.256, 6.2208, 0.62208 equals 4.9 dH dt. All right, so I can solve for dH dt here. I'll just add these two together. .324 approximately. Yep. What should my units on that be? Miles per minute? Yep, because my x and y's are both in miles, so my h will be in miles, and my time is in minutes, miles per minute. Yep. All right, so that was similar to other related rates problems. It just had the little wrinkle in that the known rates of change weren't given directly. You had to sort of come up with an approximation. Okay, so that's my only example for today. Okay, so your group activity is to continue working on the related rates homework. from the scanned related rates problems. You have the answers. If you finish that homework, or if you've already finished that homework, move on to the problems that follow. I think I gave you like 3 new ones. If you happen to have finished already, or if you finished before class is over.